Right, well, it's my pleasure now to introduce our first speaker of the day, and that's going to be Nicole Bijlsma. Nicole is an accomplished naturopath, acupuncturist, and a building biologist who has been in practice since 1989. Nicole is a woman of passion, and her passion lies in environmental medicine. She first came to be involved in building biology when she began to notice the extent to which the environment was causing illness in many of her patients. Nicole is the author of Healthy Home, Healthy Family, and the founder of the Australian College of Environmental Studies, offering nationally accredited training in building biology. So she's beginning her talk today with one on mould and biotoxins, a chronic inflammatory response, including the causes of moisture intrusion, adverse health effects, and mould remediation. Thank you, Nicole.
Well, welcome to my talk on the mould patient. As Tim mentioned, I'm a building biologist, which essentially means I go into people's homes to determine if their house is making them sick. A lot of the work that I do now deals with kids on the spectrum, autistic spectral disorders, kids with allergies, and particularly people with chronic fatigue syndrome. My first introduction to mould occurred as a result of clients with chronic fatigue syndrome. And over a period of 15 years, I noticed that many patients with CFS would state at some time during their treatment, normally within the second or third consultation, do you think there's mould growing in my bedroom or my house? Do you think it could be contributing to my illness? And I said, I really don't know. I didn't learn about mould when I did my double degree. And it was an interesting thing that I didn't think much of until a 35-year-old woman came into the clinic. And she had just been hospitalised twice with pneumonia in the past 12 months. She had severe candida. She had oral and vaginal thrush. She had tinea in her hands and her feet. She was extremely cold. She was diagnosed with chronic fatigue syndrome. She had fibromyalgia. She had everything. And in the second consultation, I asked her about her home. And I said, look, how long have you been, tell me about the house you live in, how long have you been there? She said, look, I'm living with my brother in Surrey Hills in Melbourne, and I've been there 18 months. I said, well, that's really interesting because you said 18 months ago your symptoms began. She said, yeah, that's an interesting coincidence. I said, well, tell me about the house. Is there any issues with the house in terms of, chemicals or mould or anything? She said, actually, there is a problem with mould. If I put my shoes under my bed, within the next morning there's fur, and that's how she described it, fur growing all over them by the morning. Okay, that's not great. She said, yeah, it's quite damp and musty and there's visible mould in my bedroom and pretty much everywhere in my bedroom. I said, where did that come from? Where is the water coming from? And she said, there's a problem with the gutter on my bedroom side and my brother refuses to fix it because he wants to bulldoze the house in 2 years' time. So he doesn't want to do any renovations or maintenance. And when it rains, the water comes from the gutter down into the subfloor under the house and is creating this remarkable rising damp issue that's affecting her bedroom. And I said, well, forget pretty much everything I've given you and the shopping bags full of stuff I've given you. You need to get that assessed immediately and I'll look into it. And when I started looking into the evidence of mould at that time, a lot of the research was showing adverse health effects in livestock because of animal feed and outbreaks and where animals have died as a result of mould-contaminated feedstock. There wasn't a lot on evidence-based information for people affected by mould-related illnesses, and certainly very little on chronic fatigue syndrome and things like this. That is until 1994, when an outbreak of infant lung bleeding occurred in infants in Cleveland. And as a result of this outbreak, the Centre of Disease Control was encouraged to come and investigate why 30 babies in Cleveland in the USA were exhibiting hemoptysis. Lo and behold, 9 babies died, and eventually after many months of investigation, they discovered that there was a flood in this particular part of Cleveland which caused water to accumulate in their basements. And in America, their building is very different. The type of building materials they use and how they build homes is quite different to Australia. They have enclosed basements. And water had got into the basement, and because the return air vent was in the actual basement, it was drawing air from the basement into the rest of the house, because of course it's quite cold in several parts of America, so that makes sense to do that. But unfortunately, because there was water there, within 24 hours, whatever microbes are sitting there in the basement area, it enables Stachybotrys, a type of fungi, to start proliferating and germinating and releasing spores and hyphae fragments, etc., which got into the HVAC system, and babies that were sleeping closest to the diffusers and the floor registers were the ones who were most susceptible to the lung bleeding. It wasn't until 2008, however, that the US developed or released a document, the Government Accountability Office report on mould, and then a year later the World Health Organization released a report on indoor air quality, mould and dampness. And that really set the scene for adverse health effects associated with mould and adverse health outcomes in patients and humans. Fungi are ubiquitous plant-like organisms. These guys are unbelievable. They will survive ice ages, they'll survive meteorites. They're the ones who are going to survive everything, because they are nature's greatest decomposers. They have a remarkable ability to adapt to their environment. And if you give them what they want, they're going to be in your environment, because you'll find the spores from the Arctic to the Antarctic. They are everywhere, on every surface, on you, on animals, plants, and everywhere on this planet. So we live in symbiosis with these organisms. However, they can become pathogenic under certain circumstances. There are over 1.5 million different species that they're aware of. No doubt there will probably be more as time goes on. 300, some say 400 are known to be pathogenic to humans. In terms of what we know about fungi and disease, we know that certain types of fungi can cause disease, and I'm sure many of you will be familiar with this. So aspergillosis or fungus ball, causing affecting immunocompromised patients and people with pre-existing lung disease. I actually don't want to go through all of those. These are recognised diseases associated with certain types of fungi. Cryptococcus, of course, with birds, blastomycosis, etc. in farmers. We have histoplasmosis as a result of bird and bat droppings, etc., etc. So there's certain types of fungi which are associated with specific disease states that we are aware of. Candidiasis, of course, being a common one, especially with antibiotic use, etc. What I find of interest, however, is that there are certain diseases that are not IgE-mediated responses. So with the fungi that we know that many asthma sufferers are susceptible or allergic to fungi. The great majority of asthma sufferers are. And it's often an IgE-mediated response. However, what we are finding is that people can have adverse health reactions to fungi that may not necessarily be an IgE-mediated response. Now, in the reports by the World Health Organization and the US Government Accountability Office, they have concluded that there's sufficient evidence of an association to indoor dampness. So dampness implies moisture intrusion coming within the building. As soon as you have moisture sitting on a surface for more than 48 hours, you're going to enable the right environment for bacteria and fungi to start proliferating and germinating. So they have indicated that there's sufficient evidence of an association of flu-like symptoms as a result of mould. Nose and throat irritation, fever, cough, headache and nausea. Allergic rhinitis, of course, is something that occurs as a result of mould. Exacerbation of asthma and hypersensitivity pneumonitis. So this is what is acknowledged of how mould can affect adverse health outcomes. Diseases in humans. Limited evidence of an association. Didn't switch it on, did I? Great. Now can you hear me? Yeah. Limited evidence of the following. In subacute cases, lung disease in healthy children, shortness of breath and cause of asthma. There is insufficient evidence to indicate in chronic conditions, chronic exposure to indoor dampness and mould as causing fatigue, skin reactions, digestive pathology, reproductive illnesses and mental illness, cancer, rheumatic and other immune disorders and lung bleeding in lungs. Although the American Academy of Pediatrics in 2006 concluded a very plausible link exists between lung bleeding in infants and exposure to mold toxins. Now, what I find of interest that in the last, since around the mid-2000s, something has changed quite dramatically in relation to our understanding of chronic fatigue illnesses and in particular exposure to biotoxins. Damp building related illness is a type of sick building syndrome associated with prolonged exposure to a water damaged building with only a portion of the exposed developing symptoms. So damp building related illnesses is where water comes into the building or as a result of housekeeping issue or flooding or problems with gutters or anything like this where water sits for more than 24 hours, 48 hours, enabling this bacteria and fungi to start proliferating. In the mould remediation industry, we call this a water damaged building. It may include hypersensitivity pneumonitis, etc., and pulmonary mycotoxicosis if they are caused by damp buildings, but this is actually quite rare. So damp building related illness is something for which we really do not understand much about this, and there is no well-defined diagnostic criteria. However, this is changing. What we do acknowledge, and the World Health Organization has acknowledged, is that a water damaged building, that the cause is not likely to be due to one fungi or one bacteria, that in fact it's likely to be due to an incredible complex stew of inflammagens and toxins and mycotoxins, including bacteria and fungi, the mycobacteria, spores, hyphae fragments, mycotoxins, protozoa, etc., etc., and of course microbial VOCs. That in a water damaged building, once you have water there, you've already got the food there for the bacteria and the fungi, because most building materials are cellulose based and it's the perfect medium and food for these microbes to feed. So because that's there, the water is the key that will enable them to grow.
Do you include domestic residences that are underventilated?
Yes, absolutely. And look, there's a huge problem with the way in which our buildings through the building code are now built, because they're so tight that any type of activity such as your laundering, your washing machine, your dryers, if that humidity isn't vented to the exterior, you have the perfect scenario for mould, for condensation to occur and therefore mould to become a problem. And the Building Commission are currently aware of the fact that a lot of the newer buildings are creating mould related issues because there's such poor passive ventilation. Yeah. So anywhere that draws humidity, condensation, and an important question we ask our clients is, how long do you get any form of condensation when you have a bath or a shower? You shouldn't. There should be adequate ventilation. The exhaust vent should actually exhaust that humidity to the exterior, not to the roof cavity. Because once it hits the dew point, once you get steam into a roof cavity and hits the dew point, it condenses. And where it condenses, you're going to have microbes there, and they're going to use the water in order to start germinating. So what the World Health Organization is saying is that there are illnesses that could affect people that are not IgE mediated responses, that could be due not to just one fungi, but actually this complex stew of microbes from bacteria and fungi and all their byproducts. Richie Shoemaker has termed this a chronic inflammatory response syndrome, and he was first introduced to this as a result of an outbreak of Listeria along the eastern seaboard of North America. Many of his patients were displaying chronic fatigue type symptoms, and this was occurring for those who were living near these estuaries and waterways where this algae was blooming in this part of America. And these unusual illnesses were developed in the workers who were working in the estuaries, but also the people who were living near them. And he eventually termed it chronic inflammatory response syndrome. He analysed over 12,000 patients with chronic, what we would refer to as chronic fatigue syndrome, and he found that their pathology was negative for full blood examinations, and any type of pathology test was coming up negative. When he started to look at the inflammatory biomarkers, he found a very strong correlation that in fact that this could be an inflammatory disorder. And through his analysis and doing DNA testing, he found that 24% of the population do not create antibodies to certain types of fungi. And as a result of this, every time they go into a water-damaged building, instead of stimulating the acquired immune response and an antibody response, what happens in this 24% of the population is they set up the innate immune system, which is an inflammatory response. So the person sets up this inflammatory response which doesn't stop, and it's the inflammation and its impact on neuropeptides like melanocyte stimulating hormone and antidiuretic hormone. It's its impact of the cytokines in the periphery restricting oxygen flow to the capillaries, to the muscles, causing all of these fibromyalgic symptoms, sleep disturbances, etc. And so what he's saying is that the disease is actually due to the patient's inability to deal with these microorganisms, setting up a chronic systemic inflammatory response. Every time they would go into a water-damaged building, they would get sicker quicker. So that's what I really want to describe in this lecture, is the process by which the innate immune system could be responsible for the chronic fatiguing illnesses we can see with patients in a water-damaged building. And that in fact chronic fatigue syndrome may not actually be an accurate diagnosis, that in fact it could be a chronic inflammatory response syndrome. The innate or non-specific immunity is the first line of defence that detects invasion of microbial pathogen. It's the first line of defence whenever a microbe comes into play. Recognition of microbial components by toll-like receptors triggers the expression of genes, which instructs the development of antigen-specific acquired immunity. So what happens when someone gets exposed to microorganisms? The first line of defence, which is the innate immune system, gets involved. And this involves pattern recognition receptors. So they recognise it and then they present these antigens to the B cells, which produce antibodies, and then every time they get exposed again, the acquired immune response kicks in and then they get rid of the microbes before they even know that they're infected. This is what happens in healthy clients. The US Government Accountability Office and the World Health Organization recognise that inflammation may in fact be related and a cause of mould-related illness that's not IgE mediated. So in healthy individuals, just to summarise, the biotoxin is tagged and identified by the body's immune response and is broken down and removed from the blood by the liver. This does not occur in some patients with a defect on the human leukocyte antigen or HLA-DR gene set on chromosome 6. And Shoemaker in his research was indicating that 24% of the population do not have this HLA-DR gene set expressed in their genotype, which means every time they go into a water-damaged building, they set up a chronic inflammatory response. So they don't have the immune response genes on chromosome 6 required to form antibodies against these biotoxins. Consequently, the innate immune inflammatory response, which subsequently ensures, wreaks havoc on multiple systems in the body. And I'm going to go through the different stages when a person with this DNA type goes into a water-damaged building, how it can set up inflammation, which cells can be involved, and why their symptoms develop. It can affect everything from the central nervous system, so you can get sleep-related problems, to the musculoskeletal system and fibromyalgic symptoms, to the gut. Many of these clients can actually develop antibodies to gliadin. Now, I know nutrition and leaky gut syndrome has become a big issue because it is a big issue in our society. But what I find of interest in this is that many people that we deal with in clinic is they're not born with celiac disease. They don't have gliadin intolerances often early on in their life. A lot of adults can develop these because of this process. So what can happen is that the inflammation that occurs and the microorganisms that are in their system, and particularly in their mucous membranes, they can create toxins which create this inflammatory process going. And the way in which children deal with this when they have infection is they swallow their sputum and it's infected with these microorganisms, with these fungi and bacteria and all their mycotoxins. And what do these things do when they're in the gut is they actually can affect the probiotics within the gut, which could make them more susceptible susceptible to being sensitive to gliadin. So in fact, it could indicate in some of these patients that the gluten or the diet is not the cause of a lot of these gut dysbioses, but it could actually be exposure to mould and other forms of biotoxins, which are setting up this inflammatory cascade of events, which are then enabling these microbes to survive within their system, create mycotoxins that when they are put into the gut through the enterohepatic system, that they're actually changing the flora within, the probiotic flora within the gut, and then making them more susceptible to gliadin and to wheat and to other types of foods, which is actually quite a radical way of looking.
Do you want questions as we go, or do you prefer them at the end?
We'll do that.
Just to say, I forgot to say at the beginning, although that's the normal format, for this, because it's being filmed, if we can try and leave questions at the end, we've got to use a microphone, and it's easier to do it that way. I know it breaks it up, but on the whole, you just write them down and we'll come back.
This was first termed in 1972. This is actually not a new theory. In 1972, a research paper by Dr. Lewis Thomas in the New England Journal examined how an individual could respond to bacterial endotoxins, and he suggested that in some types of people that the way in which the person responds to the biotoxins can result in an inflammatory cascade of events that is causing the illness, because of their inability to deal with these microbes and their byproducts. But it wasn't until Charles Janeway in 1989 who proposed the acquired immune response is controlled by the innate immune system. He referred to this as the pattern recognition theory. So in the acquired immune system, it relies on receptors on T cells and B cells to recognise very specific microorganisms. But in the innate immune response, in our first line of defence, this doesn't happen. We rely on pattern recognition receptors. They include toll-like receptors, C-type lectin receptors, nod-like receptors on dendritic cells and within the intracellular, within the cell itself. So these cells recognise pathogen-associated molecular patterns, or PAMPs. So the first line of defence doesn't recognise microorganisms specifically like the acquired immune system does. Rather, it relies on these pathogen-associated molecular patterns in the microorganisms, which are found on the microorganism's cell wall and within the DNA of the microorganism. And once they recognise it, they then bind to these microorganisms and then present it to the T cells, which then get the acquired immune response happening. So this is the first time that they started to look at that in certain people, that when they're exposed to microorganisms, it sets up this systemic inflammation that does not shut down. It results in fatigue, headache, light sensitivity, brain fog. This is probably the most common symptom that I get with most of my clients that I deal with chronic fatigue syndrome and electromagnetic hypersensitivity. What I find so startling about this understanding of biotoxins is that it explains the mechanism by which electromagnetic fields could actually be affecting the body. Brain fog is often memory loss, poor concentration, anomia. These people will stop mid-sentence because they forget words. That's what anomia is. Vertigo, dizziness, confusion, disorientation and mood swings, and often these patients are misdiagnosed with mental illness when in fact there is a very strong correlation with understanding how these microorganisms and this chemical stew of inflammagens can affect neuropeptides such as melanocyte-stimulating hormone and vasoactive intestinal polypeptide, which are very important neuropeptides involved in our brains. So these are very typical symptoms in people with chronic fatigue syndrome, but actually in biotoxin illness and also in electromagnetic sensitivity. Musculoskeletal symptoms that people get are aches and pains and joint pains. Why? Because when you set up an inflammatory response in the capillaries, what happens is it attracts white blood cells and it creates a restriction of oxygen to the muscles. So they end up with high levels of lactic acid in their cells, and this is causing a lot of the muscular aches and pains that you get with people with fibromyalgia and with chronic fatigue syndrome. Often the symptoms are worse in the morning and there can be tremors in some cases. Red eyes, blurred vision, tearing. This is particularly so if there are high levels of airborne microbes such as fungi, spores and hyphae. A new paper has come out which is due to be published next month by Shoemaker, and he explains the detail and the pathology involved with how cognitive impairment is observed in patients with chronic fatigue syndrome and biotoxin. He has stated that in specific haplotypes, i.e. in the 24% of people who don't create genes to these biotoxins following exposure to a water-damaged building, it's likely to be due to an increase in the permeability of the blood-brain barrier arising from chronic systemic inflammation. As a building biologist, most of the illnesses I see are chronic fatigue syndrome and electrical hypersensitivity, and often there's a very strong connection I'm finding now with mould and EMFs and its impact on cognitive impairment in these patients. I actually think chronic fatigue syndrome is a misdiagnosis and should only be done once you've excluded electromagnetic fields and mould as a potential source of illness. In the gut, they can get abdominal-related problems, and this is because melanocyte-stimulating hormone is a neuropeptide that has a very important role to play in gut pathology. It can cause diarrhea, a metallic taste in the mouth, and appetite swings. It can lead to skin sensitivities. If macrophages are involved, it can lead to inflammation within the skin, and numbness and tingling. Night sweats and temperature dysregulation. Many of my clients don't thermoregulate very well. They're often very, very cold and they don't have an ability to get warm. If the antidiuretic hormone or vasopressin is involved, which can occur in the last stages of the inflammatory response, they often have polydipsia, excessive thirst, excessive urine, and increased likelihood of static shocks. So when I'm going in to do an audit of a client who has mould in their house, often what I find is, and I ask them, how often do you go to the toilet? They said, oh, my husband laughs about it. I go every hour. During the night, I have to wake up regularly. You know, I'm not pregnant. It's like I'm pregnant again. I don't know what's going on. I said, are you easy to shock when you touch things? She said, it's a running joke in the family. And I'm finding this very interesting that these patients exposed to mould and to EMFs have this alteration or dysregulation in antidiuretic hormone. That in fact, because of the changes in their osmolality in their blood, they have higher levels of sodium which make them more susceptible to electric shocks. And these are key symptoms that we need to look out for that could be related to mould-related illnesses. In the lungs, of course, mould and its cause of lung disease is well established in the scientific literature. We know it causes sinusitis, we know it can cause pneumonia and cough and shortness of breath. What intrigues me about Shoemaker's work is that he's finding a lot of patients with chronic fatigue syndrome don't have respiratory symptoms because the 24% of the population don't create antibodies. So they're setting up this chronic inflammatory systemic inflammation which is affecting neuropeptides which ultimately affect their sleep, affect their musculoskeletal system, affect their gut. And then they become intolerant to gluten. They become intolerant to foods. The foods aren't the cause, it's the systemic inflammation that's affecting the probiotics, which is really quite a radical way to look at how we deal with these patients. So let's have a look at the 7 stages by which this occurs. Biotoxins bind to pattern receptors. I've mentioned them, the toll-like receptors on dendritic cells. Dendritic cells are antigen-presenting cells. So these cells attach to the microorganisms, or the PAMPs, and then they present them to the T cells to initiate an acquired immune response. These biotoxins bind to these receptors, which are found on almost every cell in the body. And this results in an upregulation of multiple inflammatory pathways, including the production of cytokines, such as your interleukins, your split product of complement, particularly C4a, the matrix metalloproteinase 9, which is a very strong inflammatory mediator, and TGF-beta1. And I'm going to talk about each of those inflammatory mediators in a moment. C4a, normal. Now I've given you the ranges for this because in Shoemaker's work, and not just Shoemaker, there's several scientists who are doing this, they've found that these are the inflammatory markers you want to test in blood. These are the normal ranges, the C4A. The C4A is typically very high in patients who have chronic fatigue associated with mould or biotoxin-related illnesses. C4A is a local inflammatory mediator that increases vascular permeability. It induces histamine release from mast cells and stimulates smooth muscle spasm in the very small capillaries, causing capillary hypoperfusion. And this causes a lot of the coldness, but also the spasming in the periphery. These levels can go up very, very high within 12 hours of exposure to a water-damaged building. So you'll find that it's an interesting thing about Shoemaker's work with thousands of patients he's dealt with is that within 12 hours of going into a water-damaged building, the C4A levels will just skyrocket. With MMP9, an enzyme biomarker for the presence of excessive cytokine production in most inflammatory diseases. This one's very high in patients with multiple sclerosis. This is also high in chronic obstructive pulmonary disease. It's high in rheumatoid arthritis, and it's high in biotoxin patients. It's a very important inflammatory marker in these chronic inflammatory diseases. And asthma, of course, can be added to that as well. Transforming growth factor beta 1, the normal ranges are below 2,380 picograms per ml of blood. It's an inflammatory mediator with connective tissue disorders like MS, Lyme, asthma, and chronic obstructive pulmonary diseases. It alters T regulatory cells, which are involved in autoimmunity, so it can up and down regulate autoimmunity. It regulates cell growth and differentiation and wound healing. This is the markers that they are using now in the States to identify inflammation in these patients exposed to mould and other biotoxins. TGF-beta1 may play a role in the inflammation and structural changes observed in asthmatic pathways. In fact, there are thousands of research documents in the scientific literature to associate TGF-beta1 with asthma. But in fact, what they're stating is that it's also involved in mould-related illnesses. The impact of cytokines or inflammatory markers. In the brain, the cytokines bind to the leptin receptor, which inhibit the production of alpha melanocyte stimulating hormone. This is the major cause of the brain fog that you see with patients exposed to mould and other biotoxins. Other biotoxins could be microcystis from blue-green algae. Knowing where your patients live is critical to the ability to understand if biotoxins is a problem, because I get a lot of calls from people living around New South Wales near the lakes who are having these unusual chronic fatigue symptoms that could be related to dinoflagellates or the byproducts of blue-green algae as a result of exposure of living near these lakes and estuaries. So where people live is a critical part of determining and investigating potential causes. Increased levels of interleukin-1 have also occurred as a result of an increase in the inflammation caused by cytokines. Leptin. In a male, the leptin levels are normally between 0.5 and 13.8. You've got the levels there in your notes. It's an adipocytokine produced by fat cells in response to rising levels of fatty acids. It promotes the storage of fatty acids. It controls how they are mobilised from the fat cells. It binds to receptors in the hypothalamus to produce melanocyte-stimulating hormone. High levels of cytokines will lead to leptin resistance. Now, the important thing about this is that many patients with chronic fatigue syndrome have unusual fluctuations in their weight. What can happen in certain percentages of these patients is that they can actually start gaining weight and gaining fat. And because they cannot use fat as a source of energy, they start burning up their protein. So they actually get atrophy of their muscles. This is with long-term exposure to water damage building. Atrophy of their muscles because they aren't able to use fat as a source of energy. And we refer to this as leptin resistance. Because of this, what happens is that the receptors that are involved, it affects MSH, which I'll go into detail why that neurotransmitter is so important in the pathology associated with mould-related illnesses. So melanocyte stimulating hormone, or MSH, normally ranges between 35 and 81 picograms per ml of blood. It's involved, as its name suggests, in the pigmentation of the skin and hair. But what of the most amazing effect and function of this neuropeptide is that it's involved in inflammation. It acts on the pituitary to regulate the production of melatonin, which of course is our sleep peptide. It's a very important anti-cancer hormone, melatonin, and it affects our circadian rhythms. The interesting thing in these patients with chronic fatigue syndrome is that they don't sleep well. They don't sleep during the night, they don't sleep during the day, they never get full REM-related sleep. And the reason is because it's affecting their melatonin levels through the impact of melanocyte-stimulating hormone. So this is the key. If you don't sleep, all the other systems shut down, and this becomes the big problem with the chronic fatigue, which makes it an ongoing spiralling event until you can get to the cause, which is often the biotoxin in the first place. Because MSH also regulates endorphins. So what happens is patients with CFS get these unusual forms of pain in their body because their ability to produce endorphins is significantly compromised. So they get pain and unusual pain in various parts of their body. It is also involved in inflammation. It is one of the really important mechanisms used by the innate immune response, which is the first line of defense to prevent and reduce and downregulate inflammation. It downregulates pro-inflammatory cytokines like your interleukins, and it upregulates anti-inflammatory cytokines, which are other types of interleukins. It also has antimicrobial properties, and this is a really important one to know. Because MSH stimulates melanin production to generate oxygen-free radicals, which can actually get rid of a lot of the microbes within the systemic circulation and within the mucous membranes. It indirectly stimulates immune function, and it directly inhibits pathogen proliferation. So what happens in a lot of these patients with CFS is that they have, because of the lack of melanocyte-stimulating hormone, they create marcons within the mucous membranes, multiple antibiotic resistant coagulase negative staph bacteria that survive in their nasal passages and create toxins that keep this inflammation going on and on and on, and they do not respond to antibiotics. Oh, they respond to antibiotics, but they will come back, because if you don't address the MSH, what happens is these toxins continually elicit a systemic inflammatory response. So part of the treatment protocol they've found with treating patients with these illnesses is that they have to address the marcons in order to make sure, and do high nasal swabs for these marcons, because if they give them treatment, they don't respond. They're the patient that never responds to anything because they've got bacteria sitting in their nasal passages that create toxins that set up this inflammation process that affect MSH, that continue the sleep disturbances, that affect the cytokine response and oxygen to the periphery, and they never get better. So high nasal swabs become critical to get rid of these bacteria, to stop them creating toxins. Now, as I mentioned, my concern is a lot of the work I do is with children. And what do children do when they're exposed, when they have an infection, is they swallow their sputum. So you swallow their sputum, which has these microbes in it and all their toxins, you can change the probiotics within their gut. So we focus on nutrition, which is critical, but I'm saying as a naturopath, we have to address the cause, which could actually be due to the biotoxins of the mould in that kid's bedroom, which actually created the gluten intolerance in the first place. Vasoactive intestinal polypeptide, very, very important neuropeptide. There are 3 involved with this systemic inflammation. It's a neuroregulatory hormone that regulates the peripheral cytokine responses. It regulates pulmonary artery pressure. It also induces smooth muscle relaxation in the gut. The important one about this is that this is the one that causes the symptoms where the patient walks and then they're so exhausted they have no endurance because of the impact on the pulmonary arteries. So this is a really important part of the inflammatory cascade of events that happen with patients with chronic fatigue syndrome. So so ultimately they get this capillary hypoperfusion. The circulation is restricted because the inflammation in the periphery, in the capillaries, which attracts the white blood cells, which is causing this innate and also acquired immune response, is leading to restricted blood flow, restricted oxygen, and a buildup of lactic acid in their tissues, which is causing the pain associated with which we often see as fibromyalgia. Vascular endothelial growth factor is a polypeptide made by cells that stimulates blood vessel formation and increases blood flow to capillaries. This is often significantly decreased in clients with the systemic inflammation. Reduced VEGF leads to fatigue, muscle cramps, and shortness of breath. So the immune system affects certain HLL genotypes, 24% of the population who can't create antibodies to these fungi and bacteria and their byproducts may develop an inappropriate immune response, which can include antibodies to gliadin, actin, ANCA, which is a type of ulcerative colitis, and cardiolipins in issues with blood clotting. Some of these, depending on whether they have von Willebrand's profile or not, can get nose bleeding. So a small minority of these patients can actually get nose bleeding as part of their symptom exposure. As I said, what I find so interesting about this is that this can cause the gliadin sensitivity. It's not diet related. It's actually an inflammatory response triggering this in the first place. Of course, getting rid of the gluten out of their food you have to get rid of the gluten out of the food because now they don't tolerate it very well. But the thing that interests me as a naturopath, which frustrated me as a naturopath, is, I was trained in 4 years to give bags full of stuff to my patients and treat symptoms. I want to get to the cause. And this is where it's interesting research like this is finally being able to understand the causes of these patients with chronic fatigue, which actually might not be chronic fatigue, but actually biotoxin related illnesses, which can be treated if we look at it as an inflammatory disorder. It activates the complement system, particularly C4a. Reduced MSH, therefore, in summary, results in decreased melatonin. I've mentioned sleep disturbances. It suppresses endorphin production, chronic and unusual pain. It causes malabsorption or leaky gut syndrome, which further weakens and dysregulates the immune response. Because these microorganisms, because the way in which the body gets delivered then changes these microorganisms, it puts it into the bile is secreted into the gut, and what happens is it then gets through back into the enterohepatic circulation, so it affects the bacteria and the probiotics in the gut because it's trying to get excreted that way, but then gets absorbed through the enterohepatic circulation, sets up the whole inflammatory cascade of events at the same time. This is why the most important drug they use with patients who have this, that is quite miraculous apparently, is cholestyramine. Cholestyramine is an old-fashioned anti-cholesterol drug, and what it does is it binds to cholesterol and bile, and in that bile are all the microtoxins and their byproducts, and the results they're getting from this drug is unbelievable. Now, I'm not a GP and I'm not saying to use it, but I'm just saying this is what's going on with these types of patients by progressive GPs in other parts of the world, and they're finding remarkable responses because if you're not binding these bacteria in the gut, not only are you changing the probiotics in the gut flora by their exposure, but you're actually then reinfecting the client with this inflammatory cascade of events so they get sicker quicker. And this is why so few of us have good results with patients with chronic fatigue syndrome.
You just can't get it without aspartame though. If anyone could tell me where to get it without aspartame, I'll be...
Can we wait till the end?
Yeah.
Some stuff on that.
Antibiotic-resistant staph infection, I've already alluded to. Reduced melanocyte-stimulating hormone allows resistant staph bacteria, the MARCONs, multiple antibiotic-resistant coagulase negative staph bacteria, to survive in the biofilm on the mucous membranes. That's why high nasal swabs are critical. You have to check it because if you give cholestyramine and you treat the patient with all the nutrition which is essential, they won't respond until you get rid of these bacteria, and antibiotics, of course, is required for that. These bacteria produce exotoxins A and B that cleave melanocyte-stimulating hormone, which further decreases the MSH levels, so they get sicker quicker. Now, when I finished working as a naturopath and acupuncturist before I had my twins, chronic fatigue was becoming bread and butter for us. And while they were on our treatment with supplements, they improved about 50%. But as soon as they came off, the symptoms come back again. So we have to start looking at the cause. And I look at the literature and I go, why aren't we looking at this? Because there isn't a lot of money to be made by drug companies to get to the cause of patients' illnesses. A lot of the research and the funding for the research is going to people to create drugs instead of looking at the cause. And it's very frustrating as a holistic practitioner trying to help patients when the cause is eluding us. So this is what excites me about this biochemical pathway, because it matches what I see with patients with electrical magnetic sensitivity and chronic fatigue and multiple chemical sensitivity and mould. It fits everything. Antidiuretic hormone. In a percentage of patients with biotoxins, their ADH levels are a real problem. So they end up getting these very unusual symptoms that I've talked about, i.e. they get this excessive thirst, excessive urination, and easy to be shocked by touching things and getting these electric shocks. That is a sign that antidiuretic hormone is involved. So checking the ADH levels and the osmolality becomes an important part of the pathology and screening. So it controls the amount of water that the body removes. Reduced MSH can decrease ADH, which can lead to these symptoms I've mentioned, as well as hypertension, neurally mediated hypertension. This is a common symptom with patients with chronic fatigue, and electric shocks from static electricity. Pituitary hormone effects. The pituitary can upregulate the production of cortisone and ACTH. So the pituitary has an important role in inflammation, in reducing the inflammatory response. So it can temporarily, in these patients with chronic fatigue, it can upregulate ACTH and cortisol in the very early stages of illness. But what happens in the later stages of illness with chronic fatigue is that their levels of cortisol are dangerously low. The worst thing you can do is prescribe prednisolone, because it's their last line of anti-inflammatory defense and it will knock it out quicker than anything else. So they've found that patients that are given prednisolone in the chronic stages of chronic fatigue are much, much worse, because it's the last line of defense by the body's ability to try and deal with the inflammation. So if you're giving it to it artificially, the body system to produce cortisone shuts down, and it makes them a lot sicker, a lot quicker, even though it's an inflammatory disease. So taking cortisol levels morning, noon, afternoon, midnight readings become important. Hypothalamic dysregulation. The hypothalamic trio involved in the systemic inflammation is melanocyte-stimulating hormone, antidiuretic hormone, which may or not be involved with some patients. Not all patients would have this ADH changes, but definitely VIP and MSH. And here is the biopathway. So I have photocopied the biotoxin pathway. It is brilliant. It explains all of the symptoms you find with chronic fatigue syndrome. It explains the cytokine pathway, the hypothalamus involved, MSH, how MSH affects ADH, cortisol levels, sleep disturbances, melatonin. It's all there. It's in one chart. So I want you to learn this for homework tonight before I see you tomorrow. But it's brilliant. And the thing I love about this chart is that it goes through the different stages, in the first stage, second stage, third stage. So as the patient gets sicker, the longer they have it, which types of cytokines are involved, which parts of the body start to shut down. Absolutely brilliant. That's pretty much a summary of the talk that I have here. This is the biopathway one that I'll give you here. So you can see here, in terms of the biotoxin, the microorganisms getting into the cells, then attaching to these pattern recognition receptors, which are toll-like receptors. They're on fat cells within our cells of our body. They then attach to these cells, and then it creates a cascade of inflammation through cytokines in the capillaries, restricted oxygen flow, causing a lot of the fibromyalgic musculoskeletal systems. It then causes the cytokine reactions and temperature dysregulation. The big one here is it's impact on the hypothalamus, that this cytokines attach to leptin receptors on the hypothalamus where MSH is produced, and then it affects ADH, it affects our sex hormones, so you have alterations in androgens and estrogens within the body, you have changes in cortisol and ACTH levels, you have increased bacteria and staph bacteria persisting in the mucous membranes, you have sleep disturbances because of its impact on melatonin, you have chronic pain because of the endorphins released, and then you have gut dysbiosis because of the microorganisms. In a normal patient, they are cleared through the liver, they are recognised by the acquired immune response, which doesn't happen in these other types of 24% of patients who don't have these HLA genes. In normal patients, it goes through the liver, it gets excreted through the bile and out through the intestines. That doesn't happen. This is what happens, and this is probably the most effective model to understanding chronic fatigue syndrome that I've come across.